Welcome to Cloud on Air, live webinars from Google Cloud. We're hosting webinars every Tuesday. My name is Maya Kaczorowski.
And I'm Manjot.
And today we'll be talking about network security controls for your containers. You can ask questions anytime on the platform, and we have Googlers on standby to answer them. So let's get started. So today we'll be covering first Container Network Security 101. How is it different for you to secure your container network than for your traditional VM network? Container network security controls, so how you can make sure that your network resources are accessed by authorized parties. And we'll dive deep into the controls that are available for you on GKE. And then visibility, how you can monitor the traffic that flows between different containers in your environment. Lastly, we'll leave some time for Q&A. So Container Network Security 101. First, how is securing containers and container networking different than VMs? Well, containers have a different surface of attack than virtual machines do. They are meant to be smaller, meant to be reduced bloat images that you deploy. For networking, what that means is that a lot of the plugins and things like that should be smaller, right? It's the same idea. You're going to want to reduce the amount of things that you add to your container images so you have fewer chance of vulnerabilities in those containers. Service isolation. Containers and orchestrators like Kubernetes have some built-in ways for you to isolate your different services and resources, including storage, permissioning, networking, et cetera. One of those things are firewalls and network policies. Kubernetes has built-in concepts to let you have isolation with firewalls between different containers in your network. Permissioning. Access control on network resources and other resources allow delegation of administrative functions without having potential compromise or other issues. So you can have a separation of duties between who sets up your containers and your networking versus who has to use those containers and that networking. And lastly, lifecycle. Containers on average have a very short lifespan. Sysdig estimates that 95% of containers live for less than a week. What that means from an attacker point of view is that it's harder for someone to persist in your network. But if they do persist in your network, you might, and then you restart that container, redeploy that container, you might not have any forensics as to what happened after the fact. This doesn't really impact networking, but might impact how you put in place certain controls.
So what are the different surface of attacks we need to be worried about? The first one, as Maya mentioned, is network resources. You might not want, as an organization, you might not want critical network resources like your LB rules, your firewalls, your peerings, to be under the control of every single project admin. You might want to have them be under the control or be set up by network and security admins. Second, private addressing. You might want to ensure that your entire deployment, including your nodes, your pods, etc., are within the secure boundaries of your VPC. Moreover, you might want to ensure that your control plane is also isolated from unauthorized access over the internet. Third, service communication. Another thing to ensure, or another surface area of attack, can potentially be service-to-service communication. So you might want to ensure or control the access of which services can talk to which other services through something like network policy, which enables you to set up those rules. Fourth, managed services access. When you're using a Kubernetes or a GKE deployment, chances are you're also using a host of GCP managed services like Container Registry or Dataproc or BigQuery and several others. Another thing to ensure, or another surface area of attack to cover, is the communication between your GKE deployments and your managed services. So looking at network security overall, the image in front of you will tell you where all those pieces fit in. So first and foremost, your deployments are within the secure boundaries of a VPC network. You have your private clusters, which have no public IPs on the nodes, and which can securely communicate to other clusters over VPC firewalls. Moreover, you have VPC service controls to control access to other managed services like Container Registry and BigQuery. On the L7 internet-facing side, you have Cloud Armor and Identity-Aware Proxy set up with your global load balancer to control access to your GKE deployments. And you use master authorized networks in your GKE clusters to control unauthorized access to your Kubernetes master. Similarly, you have network policy if we drill down within a single cluster for a setup for service-to-service communication. So let's talk about the network security controls in detail. The first thing we are going to talk about is shared VPC. So I spoke about how, as an organization, you want to delegate administrative responsibilities to your project admins, but you don't want your critical network resources to be dealt by them, but you want them to be under the network and security admins. Shared VPC enables you to do that. Private clusters help you achieve network segmentation by ensuring that your nodes are within the secure boundaries of your VPC and use only RFC 1918 addresses. And moreover, for private clusters, another thing you can potentially put in place is master authorized networks. A master authorized network puts in an IP whitelist on your Kubernetes or GKE master and ensures that it's blocked from unauthorized access over the internet. Network policy helps you achieve service-to-service, helps you segment microservices by restricting which services can talk to which other services. Now let's talk in more detail about each of those. So I spoke briefly about shared VPC, and shared VPC is what enables you to map your organizational topology to your network topology. So let's say you have an infra team and an apps team, and several apps team in your organization. You want the apps team project admins to be able to create, update, delete, and manage those clusters seamlessly, but you might not want them to set up things like org level firewalls, or you might not want them to set up LB rules and a host of other such things. So in order to have that model be present, you can use shared VPC. So you put your infrastructure project in your host, in your shared VPC, in your host project, and you have a shared VPC within that host project. Within the shared VPC, you add a host of service projects which actually have your app-specific clusters. This way, you get security and separation of roles. Your network and security admins set up the firewalls and not the project admins. You get sharing of common resources because if, for example, you have a pool of IP addresses that you want to share across that shared VPC network, you can actually achieve that. You get isolation of data in multi-tenant workloads by isolating the different projects and the subnets. And you also get more granular billing because you can actually separate out the projects. So shared VPC deep dive, as I mentioned, there is a host project, and within the host project, there's a shared VPC network. The shared VPC network itself can be divided into a bunch of subnets. And then you give your app projects permissions over a single subnet. So you give them the compute.network user permission over a single subnet. And this way, your app teams can actually create, manage, and delete clusters. But if you want to set up firewalls, let's say, then you have to go to the network admin. So you talk to the network admin and you ask them to set up firewalls for you in the shared VPC network. This way you get, as I mentioned earlier, separation and isolation of rules while still enabling you to share common resources throughout your organization. Moving on to the second one, which is private deployments with private clusters. Private clusters take your nodes off the public internet by removing all the public IPs. We used to initially require the public IPs in order to communicate with your GKE master, but that is no longer a requirement with advancements in our peering capabilities. So now, for your private clusters, the communication between your master and your nodes is completely private and within your VPC. Moreover, if you create a private cluster, by default, we enable master authorized network, which default denies all unauthorized access to your GKE master. Private clusters help you simplify the scope of some of the compliance requirements that you might have for your applications. As I said about master authorized networks, by default, if you create a private cluster, we enable master authorized network, and we highly recommend using master authorized network along with your private cluster. If you want to enable certain IP ranges on your on-premises to have access to your GKE master, you can set up a master authorized network with some certain CIDR ranges that you want to whitelist over your master. This way, you have a private cluster, and you block unauthorized access, and you allow only authorized IP addresses to access it. A brief note about shared VPC. So you cannot move from a non-shared VPC to a shared VPC. You cannot update an existing cluster in a non-shared VPC model to a shared VPC model. Similarly, you cannot update a cluster that is not private to become private, but you can add master authorized network to an existing cluster. So you might want to start off with shared VPC model first of all, then move on to creating private clusters, and then updating, removing master authorized networks. Looking deeper into how to enable it in the UI, you clearly see a network security space where you can enable a private cluster. And the moment you enable a private cluster, you see that we have enabled master authorized network where it says access master using the external IP address. So you can actually add authorized networks right underneath it if you want to over there. Network policy. So I've already mentioned how as you develop a microservices architecture for your applications, you might want to restrict which services can talk to which other services. Earlier, when in VM-based architectures, how services were isolated were usually with a firewall, a network layer firewall, which was very typically a physical device on the VM. So a service was isolated, let's say, in a few VMs, which could only talk to certain other VMs. But that model doesn't work when it comes to containers. As Maya mentioned earlier, that the container lifecycle is very short and they're very dynamic. So they keep on coming and going. So the newer way to actually control or restrict service-to-service communication and set access controls on which service can talk to which other service, you want to use network policies. Network policies enable you to ensure that, let's say you have a compromised front-end service. If you have a compromised front-end, you might want to ensure that something as critical as your payments backend pods are not compromised. So this way you can set up network policy rules for your services. So for example, in this policy here, you have ingress and egress rules, which can work on the basis of pod selector labels that you might have on your services. Or you can work on the basis of IP address rules. So you can add address ranges that have access or don't have access to your services. Network policy is enforced in nearly real time and scales with your GKE clusters seamlessly. Ingress integrations. Now, another very critical aspect of your deployment is Ingress and the communication to the internet and how Ingress actually sets up your load balancer. So we will talk about a host of features you have available to yourself to integrate with Ingress. The first one is identity-aware proxy. You can enable your employees to work from untrusted networks without the need of a VPN. And moreover, you can give them more granular access than an all or nothing access, which is typical of VPN connections. Cloud Armor is our defense against distributed denial of service attacks engine. You definitely want to have some sort of DDoS protection built into your load balancer or some sort of DDoS protection enabled for your deployments to prevent from all sorts of edge attacks from malicious actors. Multiple TLS certificate support. So this is to enable multiple SSL certificates or multiple TLS certificates for your deployments for every single domain that you own. So the first one, identity-aware proxy, which enables you IAM-based access control on per application basis. Identity-aware proxy acts as a central authorization layer for all your applications, and you can control who gets access to, on an application level basis to which all internal apps you might have, instead of relying on network level firewalls or VPN, as I had mentioned earlier. You see on the slide here how to actually integrate with IAP. The first thing you define is a backend config object. We introduced this concept of a backend config object so that we could have more GCP-specific annotations for your GKE clusters. The first thing you do is define the backend config object, and then within the spec, you set your IAP settings. The actual client you have to go ahead and create as part of your IAP setup flow, and then you just come back here and add your secret name once you generate the secret as well. And then once you've created your backend config object, you go back to your service definition and you actually add a link within annotations for the service to your backend config object, as mentioned here. As I mentioned, IAP performs authentication and authorization on per application level, and this helps you basically let your employees work from anywhere on untrusted networks. Cloud Armor, this is our DDoS protection engine. Besides DDoS attacks, it has protections built in against a host of different attacks, such as SQL injection, XSS attacks. Currently, it supports IP blacklist, whitelist, and also it has a custom rules language which you can use to have custom policies, rules set up for your applications. If you look here, you basically have to set up, again, in a very similar way to IAP. You set up a backend config object, and you define your security policy within your spec. The security policy that you define here, most of the configuration is actually a part of your regular Cloud Armor setup. And what you define here is only the linkage between the name of your security policy that you defined in your Cloud Armor setup. And similarly, once you define your backend config object, you have to add a link back to your service definition. This way, this was done on purpose because we wanted to simplify configuration for your Cloud Armor security policies and have them be done in one single place with Cloud Armor, and then just add linkages wherever possible. Visibility. So one of the most important things when we talk about security, network security, is being able to see what is going on in your network and get to know if there's any malicious actors trying to gain advantage of your network. So one of the most important things that we have for you would be VPC flow logs that can actually give you raw logs of all the flows within your network. VPC flow logs are aggregated every 5 seconds, so nearly real time, and they are not agent-based for GKE. VPC flow logs, moreover, cover all the flows within your network, whether it's to or from the internet, whether it's between services in your VPC, whether it's to managed services, or whether it's from your on-premises. Moreover, it includes both egress and ingress, and it can be enabled at the granularity of a subnet. It also covers TCP UDP flows, and it also covers a host of features like shared VPC, VPC peering, etc. A typical flow log record includes bytes, inferred RTTs. Moreover, it has several annotations that will be very useful, such as VPC annotations, which instance, which subnetwork, etc., and which region, which zone, and other geo annotations. It can be used for security analysis, network forensics. Moreover, you can also export the raw VPC flow logs in a secure manner using things like Cloud PubSub to Stackdriver logging or BigQuery or any other engine of your choosing to visualize them and track them. So here we see how to actually enable VPC flow logs. As you can see, when you're trying to create a subnet or when you're trying to edit a subnet within a VPC network, you get the option of turning on VPC flow logs. So now we move into the demo. So I think I mentioned earlier while introducing shared VPC that what is typical of organizations is you have infra or platform teams, and then you have app teams. The app teams are the ones that actually create an application that talks to users over the internet, and the infra team is the bottom layer, which sets up things like firewalls or permissions, etc. So typically what you want is the apps team to create clusters such that they can talk to the internet or just be able to manage those clusters, and the infra team to set up all those firewalls and other rules. So here, my setup would include an organization which has a host project called infra team and a service project called apps team. The host project has a shared VPC network called SharedNet, and it has one subnet called AppsTier. So the way I set up my project here is my clusters for apps team would be within the subnetwork AppsTier. And my host project has already set up firewalls and everything else for me to be able to communicate over the internet. Let's see now. So here you see details about the shared VPC network in infra team project. So these are my shared subnets and permissions. And as you can see here, basically a host of service projects have permissions, compute.network user permissions, and these are the only permissions that they have, which means my service projects in my service project robot accounts can actually use my AppSphere subnet without needing to have edit or modify permissions. You can see here that the only projects I've attached to my account are my apps team projects. Now, let's move on to actually calling. So if I move here, so you see here now that I have created 2 clusters in my apps team project. One is a private cluster, which can host a host of backend services, which don't need to be on the public internet. And my hello cluster has the most amazing app ever built, which is saying hello to Google Cloud webinar viewers. So now I will just try to call my application again and again. And here you see a host of VPC flow logs. So what I did earlier was I had enabled VPC flow log on the AppSphere and my default subnet. And how I actually get to or export my VPC flow logs is through stack driver logging. So if I come here and I drill down within my GCP subnetwork and filter by only VPC flow logs, I get to all these VPC flow logs. Do note that every single one of these records, even if I don't make any requests, you will actually see a lot of flow logs being generated because we try to cover every single flow in your network, even if you're not getting requests from the internet. And if we try to drill down here for a single request, you'll actually see the different annotations that are there. You see the VPC name, the subnetwork name, the project name. You see the source location, and you see the connection information. If you see, this is the internal IP address of my node, and similarly, that is also an IP address of the master. So you see this, for example, this record is the communication between the node and the master. Similarly, you can use this particular bar to filter on the basis of a specific pod, or if I'm making requests from my host, I can filter from my IP address or something to actually see the communication between the load balancer and my servers. So this way, you can get to flow logs for your application. Moving back.
So that was an awesome demo, Manjot. So today, hopefully, you learned a lot about container network security and some of the controls that we have on GKE to help you secure your network. But talking about container security a bit more broadly, why would you start using containers to help you achieve better security? And is that even possible? Well, as we already mentioned, containers are short-lived and frequently redeployed. So you can actually be constantly patching and updating your environment, right? You can apply a patch in your registry that then gets gradually rolled out as you would roll out any other change in your environment. That leads to a very different model for how you manage patching rather than having maintenance downtime and windows in which you have to do that kind of work. Containers are immutable, so you can ensure that your environment doesn't change. What that means is that if a container does change in production, you know something's gone wrong, and you can then kill that container and redeploy it as needed. It also means that you have content addressability, so you know exactly what's been deployed in your environment, and then if something does change, if there's a new vulnerability discovered, for example, you can compare what you deployed to the vulnerability rather than having to scan your production environment directly. That saves you a lot of time. With the control plane being managed in a container orchestration system, you can actually secure the communications that happen between the control plane and the services and between your services. So in addition to what Manjot was describing today around using network policy, using VPC flow logs, et cetera, how your control plane to node communication happens is secured. And can use encryption, authentication, et cetera. And then lastly, in terms of container security here, good security defaults are one-line changes, right? You can follow a lot of best practices like by implementing Linux changes, things like enabling seccomp or in GKE, turning on master authorized networks. It's a single change for you and your team to get that best practice. Now, what that means overall is that running containers allows you to adopt a fundamentally different security model. You are constantly patching, you are constantly redeploying. It is that kind of DevSecOps or continuous security that people talk about. but you don't necessarily lose a lot of the control you have from before. They're just different from how you were doing it with VMs. Now, on GKE specifically, obviously, we think we have great security and great network security here. So GKE provides best practices with security by default. There's always going to be app-level hardening for you to do, but more and more things are being built into the platform by default. You can check out our hardening guide online for what we'd recommend you do beyond what's already there. Things like network policy being shipped as part of GKE core has been true for several versions now. The Kubernetes dashboard is disabled. Lots of other security features built in. GKE patches you to the latest version automatically. So the control plane is patched for you by our SRE team. And then nodes you can set to auto upgrade to get patches as well. This keeps you up to date with not only the latest feature releases, including new security features and new networking features, but the latest security patches. If you've been following the news, we had a major security vulnerability that was announced yesterday. It's already patched in GKE. We had one a few weeks ago that affected network policy. It's already patched in GKE. So you get that benefit by having a managed solution. And GKE provides the best of Google Cloud security features. So there are integrations with things like IAM audit logging, but also with shared VPC, with VPC flow logs, with IAP, with lots of other things that you might want to use to improve your overall security and network security story. There's a few links for you here to learn a little bit more, including an overview of our network for containers and container security. But please stay tuned for a live Q&A, and we'll be back in less than a minute. Awesome, we're back with the questions from the audience. So, Manjot, the first one here, does network policy work to restrict pod-to-pod traffic within a node?
So you can set up network policy to restrict which services can talk to which other services on the basis of, as I said, label app selectors or IP addresses. And if that condition holds true, then you can restrict pod-to-pod traffic, whether it's within a node or between nodes.
Do I need to do anything special to set it up between nodes, or does it just kind of work?
It will just work through the policy agent.
Okay. The next question here, do I need to use master authorized networks to use private clusters?
The answer is no. You can definitely use master authorized network in isolation with or without using private clusters. We highly recommend using master authorized networks with private clusters. In fact, another recommendation I will make is you should probably think of making private clusters the default for all your clusters, unless internet access is required.
That's a good idea. The next one, do private clusters have private IP addresses for the control plane?
So there is a private IP address and a public IP address both on the master. The private IP address, as I mentioned, is used to communicate privately with the nodes. But there is a public IP address which we manage, and that we use for our internal management purposes currently.
How does Istio work with Kubernetes, and what does it protect?
Istio definitely adds a few more features on top of Kubernetes for more defense in depth protection. For example, one of the things that Istio offers is mutual TLS between services. So your services can actually authenticate and authorize while communicating with other services.
So Istio is for like service to service, but then not for pod to pod, for example?
Yes.
Okay. And then what's the recommended configuration if I want to peer my on-prem network to GKE?
So we have a host of different options under Cloud Interconnect. Depending on what kind of reliability you want, how much, how much reliable you want the connection to be, and things like that, you can choose a host of different products under Cloud Interconnect, such as VPN, dedicated interconnect, etc.
And I would set that up with a VPC or something like that?
Yes.
Or?
Yes.
Okay. Cool. So I think that's a wrap for us. Please stay tuned for the next session, CETV, Google Cloud Networking 103, Securing Your Network. Thank you.